Science is exciting. Science is important. Science is a good subject to study. You may know why science is good, but that almost never answers the question, how do you actually do science? In the first warm-up, think about your favorite science experiment. Why did you like it? Was it interactive? Did it have a cool outcome? Please remember to answer the question with as much detail as you can in the Google form. First of all, who are scientists? They are very detailed people who use a thorough process to explain everyday or extraordinary phenomena. Phenomena are observable facts or events. If you live in San Francisco, you know the fog rolling in is a common everyday phenomenon. However, you may not know that the fog rolling in is in fact caused by high pressure and temperature from inland California, drawing in moisture from cold waters of the Pacific Oceans for thousands of miles. It would be an extraordinary event if our oceans started to bioluminesce or glow. And basically, bioluminescence in coastal waters is caused by thousands of microorganisms coming in the night and glowing. One of the first things scientists do is they always take observations of their outside world. They're always curious about what's going on around them. How might scientists take observations? Please pause the video and answer this question in the Google form. What are observations? Observations are detailed ways of receiving information from the world using your senses, tools, and different instruments. A common instrument you'd use in your biology classroom is a microscope. You might use a thermometer to take temperature and a clock to take the time. If you are in a less controlled environment like outside, you may have to use a handheld lens. Your smartphone can also be a tool for taking detailed observations in your biology classroom. And last but not least, you should always remember that you have your own 5 senses for taking observations. After taking all of his observations, they might inspire you to make a question to explain or further understand your observations. Scientific questions are not as easy as, what does this mean? They often have to be observable and specific. Creating a measurable and testable scientific question is one of the hardest things to actually do in science. After creating a question, scientists then have to test it and gather some evidence in the form of data, which are pieces of information. Gathering evidence is one of the most useful skills a scientist can develop because it requires critical thinking and careful work. Evidence is used in all sorts of fields, and they're similar to observations, but evidence are observations that support a claim. We'll come back to this idea of a claim in a few slides. In the end, scientists have to make sense of their data. They have to create a claim about their experiment. They have to organize their data into evidence, and then they have to support their claim with greater scientific reasoning and logical thinking. Creating a claim and backing that claim with evidence and reasoning is a common model of scientific thinking that is known as the CER. The CER is commonly taught to high school students. Another related idea in scientific thinking is an inference. What is an inference? Most people would say it's an educated guess, but this is a common misconception. Guesses are implied to have no basis or background in reasoning or logic. An inference is more like a prediction or a conclusion that's based off of previous observations or reasoning. Sure, there is a chance that your inference may not actually come true or be wrong, but often, if you base a prediction off of solid reasoning and evidence, do you think the chances of that prediction being wrong are pretty high? No, they're probably pretty slim. Let's practice scientific thinking with an interesting phenomenon: the cat climbing the stairs. Some people have looked at this picture and thought that the cat is climbing up the stairs, whereas some people believe the cat is actually climbing down the stairs. Your job is to create a claim. Is the cat going up or down the stairs? Give evidence about whether the cat's climbing up or down, and then finally include other reasoning, like maybe a picture of your own cat or how cats typically climb or parts of stairs themselves. Pause the video and answer this question in the Google form. One last topic we're going to explore for today is the hypothesis. What is a hypothesis? It's like an inference that should happen before your experiment, not after. And typically, the hypothesis is the starting point of your experiment. The hypothesis can be wrong by the end of your experiment, and that's totally okay. Science is a process. The final question you should answer in the Google form is how a hypothesis is similar or different from a claim. Thank you for watching.